Hi guys. So we're going to start today out with the most important question you will answer all day as we normally do. So you can only keep three. Which of the three are you keeping? If I had to choose, I think I'd keep my phone, my smartwatch, and probably headphones. Anyhow, all right, so you decide what are your three things. Feel free to share with someone around you if you're with someone from class. Otherwise, just something to ponder as you start class today. All right, so moving forward, we're going to take some notes today on page 53. So if you'll open up your notebook to page 53, your essential question is, how can we predict the products of a reaction? So page 53, how can we predict the products of a reaction? And so we can determine the type of reaction based on the reactants. So we took some notes on Monday this week about types of reactions and how to figure out which type they are just by looking at the reaction. Now you're going to look at just the beginning part of the reaction, and using that beginning part or those reactants, we're going to predict what the products will be. So the first of the types is called synthesis. And so when we talked about synthesis, we said that A plus B gave us product of AB. And so I'm going to show you how it works for each one. So A plus B yields AB. I'm going to start by just saying that SR is A and oxygen is B. And so now what I can do is decide that if A and B come together, this is an ionic compound, I'm going to look for charges. So strontium SR is 2 plus, oxygen is 2 minus, and when I drop and cross those, 2 becomes the subscript on strontium, so SR2, and 2 becomes a subscript on oxygen, O2. And note that I have to reduce this, which we talked about back when we learned about ionic compounds, which gives us SRO. And so that is my product. So that's synthesis. Two things become one. We identify A, we identify B, and then we can create our product. As you take notes on this, feel free to pause so that you can write things down, make sure it goes in your notebook, because I'm not going to go as slow as I do in class, just so that this video isn't 30 minutes long. Type 2 that we talked about was decomposition, and decomposition is when two things break up to become one. And so again, I'm just going to label A and B, so it's A and B. And I know that when they break up, A goes on the first line and B goes on the second. So K is the first one and Cl is the second one. And the last thing to do in a decomposition when you're getting your two different products is to remember that you've got diatomic elements. So remember Hofbrinkel, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine are all diatomic, which means chlorine needs a little subscript of 2. Third type here is combustion. And that's when C and H and sometimes O react with oxygen gas to form carbon dioxide and water. So for every combustion reaction, when you start with something that's a CH compound and it's connecting with or going to interact with O2, we know that we get CO2 and H2O. So no need to pull anything apart or try to create new things. If you recognize it as a combustion, CO2 and H2O are your products. Next, we have single replacement. And in single replacement, remember that a single element in a compound gets a new partner and leaves another single element. So I'm going to start by, again, just labeling what A and B and C are in this so that I can create new compounds and figure out what's going to end up by itself. So when I look at my examples, I've got a compound plus a single element, and I'm going to make a new compound and a new single element. And so I'm going to highlight here what my A is. A, we're going to call A sodium. And then for B, make that green. That's my SO4 compound. And my C is my hydrogen. And so now on my lines, I'm going to also highlight some spaces so I know where things end up going. So A is going to end up being on a new line. Let's see what the best way to show you this is. Let's first pull it apart. So sodium is Na+, SO4 is SO4 2-, and if hydrogen is all by itself, the charge that hydrogen forms is H+. So I've got A, B, and C. Now, when I think about what can partner, remember that positive and negative things need to partner. So if I put sodium right here as a positive charge, I know that hydrogen is not going to partner with a positive charge because it's positive as well, which means my other positive hydrogen is going to go here, and my negative, which I said was green, is going to go right here. So let's look at that. Sodium is positive, hydrogen is positive. Hydrogen needs to get a new partner, which means sodium is going to be the thing all by itself, Na+. Now H+ and SO4, 2- are going to come together. H+, SO4, 2-. If I drop and cross these, 2 becomes a subscript on hydrogen, so I get H2. 1 becomes a subscript on SO4, SO4. That's my new chemical compound. The last of the reaction types is double replacement. And in double replacement, everybody gets a new partner. So we're going to start by highlighting again. Let's put A as sodium. We'll make XCl. B is going to be calcium, and iodine is going to be Y. So now when I break these things apart, I have Na plus and Cl minus. If at this point you're still wondering where those charges are coming from, you want to make sure you're going back to check your periodic table. Calcium is Ca2+, and iodine is 1-. Now I know every positive and negative are going to get partnered up together if we're placing them on the line. So again, let's put A here. If I go X, again, I'm just modeling it after this, right? If I look at my blue one, B goes on the second line connected to green. My last color is pink. It's Y and it's connected to A, which is the yellow color. So these colors are just helping me pull them apart. Now, if I create my formulas, sodium is going to partner with something negative. Well, it's already partnered with chlorine, so it's going to pick the other one, which means it's going to partner with iodine. When I drop and cross Na+ and I-, it's a 1-to-1 ratio, and I get NaI. Over here, calcium 2+, chlorine minus. When I drop and cross, I get CaCl2. Remember, that's when 1 becomes a subscript on chlorine, and 2 becomes the subscript on chlorine. All right, so that's double replacement. So what we're going to do now is, will you pause the screen, see if you can try a couple on your own. Once you're done or you get stuck or you need some support, I'm just going to work through each of these, and so you can pause and start as you need or as you see fit. All right, so hopefully you've now paused and then come back to see what some answers are. So let's start with the first one, and I'll solve this one in red to begin with. So right now what I'm seeing is a single element and a compound, and when I look at my different examples from before, When I have a single element and a compound, it is a single, if my pen will write it here, a single replacement reaction. I'm just going to abbreviate that with SR, which means, scroll down a little here, Na plus, Fe, and Br. I know Br is minus off the periodic table. This 3 was the charge on iron, so it's a 3 plus. Sodium gets a new partner, and its partner is going to be bromine. And so Na plus and Br minus are going to form NaBr, plus the new thing left all by itself is iron. Iron is not a diatomic element, so I do not need a subscript of 2. Now it wants me to balance, and so to balance I see that I have sodium, 1 on the left side, 1 on the right side. Bromine, 3 on the left side and 1 on the right, so I'm going to put a 3 here to balance it. My irons match, but now my sodiums are uneven. I can put a 3 here to balance my sodiums. So that's the first one. The second one, I've got 2 compounds, which means when I have 2 compounds, they're going to form 2 new compounds. And so this is a double replacement reaction, abbreviated by Dr. Now I'm going to break them into their pieces. Na plus, OH is hydroxide off the periodic table or the reference sheet you have, has a negative charge. Hydrogen is a positive charge. SO4 is a polyatomic anion on your sheet. It's a 2 minus. Everybody gets new partners. Sodium is going to partner with the other negative item, so SO4 2 minus. When I drop and cross Na plus and SO4 2 minus, I end up with Na2 SO4 plus, when I drop and cross H plus and OH minus, I get HOH, which is really H2O. You can leave it if it's easier for you as HOH because sometimes that helps with balancing. Now if I go to balance, I've got 1 sodium on the left, 2 sodiums on the right. Put a 2 on the left to make them match. Now I have 2 hydrogens. On the right hand side I have 2 hydrogens, but that's if I'm balancing only my H2SO4. So here's where that HOH comes in handy. I'm going to balance this. I'm putting parentheses there just to help show. I'm going to balance my OH with my OH, and I'm going to balance this H with this H. And so now if I take a look at my equation, on the left-hand side I have 2 OHs, and then when I'm looking at my green hydrogen, I have 2 of those. So over here on the right, if I put a 2, that makes my green hydrogens match my green hydrogens, and my 2 OHs in yellow match my 2 OHs. I'm going to erase this H2O so that it's a little easier to see. So there's your balanced equation. Number 3, I see that I have a carbon, hydrogen, oxygen compound combining with oxygen gas, which makes this a combustion. Anytime I have a combustion, my products are always H2O plus CO2. Now I can balance. Remember we balance hydrogens and oxygens last, so on the left I have 2 carbons. On the right I'm going to put a 2 in front of my CO2. When I look at hydrogens, I have 4 on the left-hand side. On the right I have 2. I'm going to put a 2 there. I'm going to double check. 2 carbons, 2 carbons, 4 hydrogens, 4 hydrogens. Now I can look at oxygens. On the left